So what did we do in the last class? We went through the basics of the vectors, the basic vectors, not forces, overall general vectors, whatever that may be. You know how to resolve vectors, I and J format, and you have the column vector form. You can write your vector in any of them, in any of the format, and work with any of the format, whatever you feel like. Okay, they won't. If they ask you to give the answer in a particular format, then you give it in that form. Otherwise, if you work with the column vector form, if you work in the IJ form, you'll get the same answer, and they won't. It won't be an issue. So I is the vector in the x direction, horizontal direction. J is the vector in the vertical direction. And adding some subtracting resolution of vectors, you just add them. And then over here, then types of vectors, we had position vectors, the vectors which are connected relative to the origin. Oh, connected to the origin. Displacement vector are any other vectors. If you want to move from one point to another point, displacement vector. Then you have unit vector, the vector divided by its own magnitude. The purpose is the direction, because for any unit vector, the magnitude is always one. So the direction, the angle which it makes with the horizontal, with the vertical, whatever the bearing for that vector is, that is more important, relevant. Then we connected the vectors with a few vector quantities that we have. We have the velocity vector, we have the acceleration vector, because these are vector quantities, they need direction as well, displacement and time. And then we have these two formulas, simple, and we derive them as well. These are very basic formulas. And this your entire questions would move around these two things properly. So understand this formula and work accordingly. Then we have the parallel vectors. When two lines are parallel, when two vectors are parallel, they are scalar multiples of each other, or you can say that their unit vectors will be same. You can also say that, because unit vector, the purpose is direction. So if two vectors are parallel, they have the same direction, so their unit vector will also be same. Or you can say that they are scalar multiples of each other. Then we did a simple question over here, and then we did this one, and then we did this past paper a little bit. And then for today's class, we have a question from your specimen. So this is a very good one, and you will get to know how the questions are coming in the exam, connecting everything right now that we have done. So reading the question, they have told us that at time 0, a bird A leaves its nest. That is located at the point with the position vector 20, comma minus 17. So this means that the nest leaves its nest. So the position vector of the nest, it is given ON. N I am calling the nest. It is 20 minus 17. Okay, one more thing that I can tell you is that may be helpful. Position vectors can also be the coordinates. Position vectors is equal to coordinate of that point, because we know that coordinate is what connected to it is relative to the origin. Whatever the coordinate is, 5, 6 or 10, 4, it is from the 0. It is from the origin, and position vector is also from the origin. So if you have a coordinate, you can write it down as a position vector, or if you have a position vector, you can write it down as a coordinate. Both mean the same thing. So you have this 0 and ON, the position vector of the nest relative to the origin, and now this bird left its nest, and its velocity, the velocity vector of the bird is minus 6, 7. At the same time, a second bird B leaves. So this is bird A. Another bird leaves its nest, which is located at a point at position vector. Okay. So this is the nest of A, and this is the nest of B, O and B, which is minus 8, 9, and flies with a constant velocity of velocity of this is the velocity of A, this is the velocity of bird B. P, 2P. Where P is a constant. At time 4, the bird B is southwest of bird A. Now this is a very interesting question. At time 4, this is bird B. Bird B is southwest of A at time 4. They are asking you find the direction of the motion of A, giving your answer as a bearing to the nearest degree. Direction of motion, that would be the direction of the velocity vector of A. So velocity of A is given to you, it is minus 6,7. Or if you make a little diagram as well, it has a negative x minus 6 and it has a positive y. So the direction is somewhat over here like this, in this direction. This is the velocity. Plus 7 and negative 6 in the x. They're asking us to give us the as a bearing. Okay, so if you want the bearing would be from the north. Bearing is always from the north. So this angle would be your bearing. This is what they're asking you. So what do? We can find this angle easily. If we find this angle theta, this would be equal to tan theta is equals to opposite upon adjacent 6. So theta will be equal to tan inverse 7 upon 6. Oh, sorry. Tan inverse 7 upon 6. And degree, sorry, tan inverse 7 upon 6. 49.4 degrees. So this is 49.4. So the total, we know this much is 270. So the total bearing would be 270 plus 49 plus 4. So this is 319.4. Okay, got it? Any questions, anyone? Look at the second part. It is of 10 marks. One question of 10 marks. So find the speed of B. They're asking you to find B. They have told us that B is southwest of A. This southwest is what? This is north. North, south, east, west, isn't it? And southwest is this direction. 45 degree, right? It is 45 degree from here and 45 degree from here. So this is your southwest. And any vector, listen to me, any vector in the southwest direction, what would be the unit vector? Because the direction is important right now. We know that the direction between A and B, if I connect the bird B and bird A by a vector, that vector will be parallel to this southwest vector, isn't it? So this means the unit vector will be same. So unit vector of this southwest will be what? You can find it out. You can break it down into components. So we know this would be, if I say that the magnitude is 1, right? For any unit vector, let's suppose the magnitude is 1. So if I break it down into the vertical and horizontal component, so this one would be cos 1 cos 45 and this would be 1 sin 45. And this would make what? This would make minus cos 45 in the x direction because it is in the left side, and sin 45. This would also be negative. Do you get it or not?
Wait 1 second. Let me see this. So you
I
told
have,
us last class that the magnitude right of the direction is always 1. Yeah. So using that, we do this. Okay.
I'm using simple SOHCAHTOA to break it down into the horizontal and vertical component.
Yeah, okay.
So 1 cos 45 is the component which is adjacent to the angle 45.
Yeah,
And
but
1
sir, what
sin
if
45.
you use what if you use the other one then, like the other down 45? Will it give you the
You will
same
get the
thing?
same answer, yes.
Okay, let me just
Because you will see
quickly
cos
write.
45 and sin 45 have the same value. Sin 45 is look in root 2 by 2. And cos 45 will also be root 2 by 2. It's the same.
Oh, right. So it's root 2 over 2 over root 2 over 2. Nice.
Yes. So we now know that at time 4, the bird B, the vector BA, you can say, at time 4, BA will be parallel to this vector, isn't it? Is negative. Because they have given you the direction at which they have told us that bird B is southwest of A. Very different from the previous all of the questions. Everything is combined now, unit vector, and this is a very good example to connect everything together. So this means I told you when two what do you say, these vectors are parallel. So they are what? Scalar multiples of each
Well,
other. So we'll have to find the value of k. We don't know what is k. Now, one more thing. If we break it down, the BA vector is what? The vector connecting the bird B and the bird A. If I open it up, this would become OA plus OB. Right? The new OA and the new OB. I told you displacement vectors can be opened up like this. It was over here. Uh, I did not tell you. Yes, you can see over here. If I connect this, I can open up this BD. How do I open up? This BD will be equal to OD minus OB. How?
yeah, yeah, yeah.
If I make this is OB
Isn't it plus?
and this is negative
Oh,
OD.
okay.
So if I want to go from B to D, what am I doing? I'm going from uh D O D D O. We are going from D. No, wait a minute. B to O and then O to D, right? So B to O. If I open it up like this, so BD, it is equals to BO plus OD, isn't it? Look at the diagram. BO and then OD. But BO, I can write this BO and like this minus OB. That would be the same thing. If I want to write them down in terms of the position vectors. So now you can see BD is equals to OD minus OB. So what do? You can open up any vector, any displacement vector in terms of their position vectors by writing down the position vector of the second letter minus the position vector of the first letter. So OD minus OB. Similarly, if you have AB, it will be OB minus OA. We will redo this question as well. I know this is a lot of information. Everything is connecting in a single question, so it can be confusing as well. So that's why I have opened it up into OA and OB. So OA and OB are the new position vectors. Now I know that the new position vector is equals to old position vector plus velocity vector multiplied by time plus OB old plus velocity vector of B time is equals to k times minus root 2 over 2 and minus root 2 over 2. Now old position vector of A, it is given to us 20, 17 minus 17 plus velocity vector is also, we know velocity vector of A is minus 6, 7 minus 6, 7, and we know the time as well after 4 seconds. What is 4 seconds, and the speed is also in meter per second, so it's okay, units are matching. Plus old position vector of B, it is minus 8, 9 plus velocity vector of B, P and 2P, and time we know it is equal to 4, and this is K minus root 2 over 2 minus root 2 over 2. Okay. Now what? We can simplify. And you can form the equations in the x direction and in the y direction. And then you can solve them simultaneously, because you can see if you will solve all of the x's, you will get an equation in terms of p and k. And then you will add all of the y's, you will get an equation in terms of p and k. So you will get two equations. So if I write down the two equations, this would become 20 minus 6 times 4 minus 8 plus 4p is equals to negative root 2 over 2k. This is your first equation. Then minus 17 plus 7 times 4 plus 9 plus 8p is equals to minus root 2 over 2k. Simplify them both. So use your calculator. 20 minus 6 times 4 plus minus 8 minus 12. So minus 12, and I'm moving the 4p also on the other side. So minus 4p and minus root 2 over 2k. Your first equation, and this would become minus 17 plus 7 times 4 plus 9. 20. 20 is equals to minus 8p minus root 2 over 2k. And now you can solve them simultaneously. You will get the value of p and k. Minus 4 root 2 over 2. Sorry. Root 2 over 2. This is also negative. And this is minus 12. And this is minus 8 negative root 2 over 2 and 20. So look, your answer of p is coming out as minus 8. And your k is 44 root 2. And if your p is negative 8, so this means the velocity of b, it was p and 2p, right? So this would become minus 8 and minus 16. And they're asking you to find the speed. So you will find the magnitude of this velocity. Square root negative 8 square plus negative 16 square. So 17.9 meters per second. This is your answer.
Wait, sir, I'm doing this right now. Can you just keep it there?
Let me confirm it. What is the value of my value of k over here is coming minus 0.5. Wait a minute. Maybe we made some.
Sir, I got P as 10.5, negative 10.5.
Your p.
Yeah.
Maybe I've put in something wrong. Minus 4 minus root 2 over 2 and minus 12. Minus 8 minus root 2 over 2 and 20. Minus 8. I'm getting minus 8.
Mister, let me see your other working out. Can you just
Go a sec. See if I made a mistake or time. Stop.
It's 17. Wait, sorry, that's negative.
I think I've done it right.
Yeah, I think I've didn't make the 17 negative. Wait, is it 20 minus 17? Like for the vector of initial of OA. What is that?
20 and minus 17.
That's minus 17. Okay, I put it positive.
Minus
My
6,
bad.
9. P and 2p. Minus 8, 9.
So it's 20, it's positive 20 and it's negative 17. Okay, let me do this again then. Give me 1 sec. -45.
I think where in this my previous working, I forgot to put it in minus root 2 over 2, and then in the next step I've forgotten minus root 2 over 2. I've just written the positive.
So what was the answer for P?
My answer is coming
P.
minus 8.
Okay.
And I have even not written down which area was it, so we can confirm it ourselves as well. Otherwise, we'll have to check it. We will see. But you understand the concept, right? Mazam, any
Yeah.
questions?
Yeah, no questions.
Okay, look, I found a mistake. So silly mistake. So silly mistake. What did I tell you? It is B. Don't make this mistake now. Oh, I told you that AB, if you want to open up anything, AB, it is equals to OB, and then we have a minus in between. And what have I put? I put in plus. So this means this is minus. Okay. And then this would become plus 8 over here, and this would be minus 4p. And this would become minus 9, and this would be minus 8p. Okay. And so this would become plus 4p. This is also plus 8p. And the values that we have found for the minus 12 and 20, we'll have to check it again. So this is 20 minus 6 times 4 plus 8. So 4, this is 4. And minus 17 plus 7 times 4 minus 9. So 2. Now if I solve it simultaneously, so 4 minus root 2 upon 2 and 4. This is 8 minus root 2 upon 2, 2. Now I'm getting it right. Okay. .118. Okay, now I feel much better. Found the mistake. So this would be negative. Don't forget now. Okay. Okay. We are moving on. Take a screenshot so that you don't forget this silly mistake I made it. Otherwise, we did everything right. So find the acceleration of P. So F is equals to ma. So force vector is equals to mass times acceleration vector. So force is 2, 3. Mass is 0.5 and acceleration. So acceleration will be equal to 0.5 would go and divide. This will become 4, 6. 2 divided by 0.5 and 3 divided by 0.5. So 4, 6. And the acceleration value will be square root 16 plus 36, which will be under root 52 meter per second square. Then at time t seconds, the velocity v. When time is 0, v is 4. Find the speed when t is 3. So time is 0 and velocity is 4, 0. Now they're asking you to find the speed. So the new velocity is equals to the old one plus the velocity, sorry, acceleration. Acceleration is 4, 6 and times time, which is 3. And then you do the square root thingy to get the speed. So 4 plus 12 is 16, and this is 18. And so the speed will be equal to square root of 16 to square plus 18 to square, and whatever the answer will be. Then, given that the particle P is moving parallel to the vector at time capital T. So particle is moving parallel to the, so this means the speed, the velocity, the new velocity, it is parallel to 2, 1. So this means the velocity 4 plus 4t and 60. This is the velocity vector, the new velocity vector in terms of t. This would be k times 2, 1. And so now you can solve them simultaneously. So you will get 4 plus 4t is equals to 2k, and 6t is equals to k. And then you can solve them simultaneously and get the value of the capital T.
Yeah. Sir, I have a question. When do you know, like for example, this is given that P is moving parallel to this vector, right? When do you know, like, do you find the velocity that's parallel to that, or
They both will
the
be equal.
position vector?
It's okay if you want to keep the velocity is equals to k times the 2, 1, or if you want to keep the 2, 1 is equals to k times the velocity. You will get the same answer.
Hmm.
It won't matter. Okay. It's just they will be inverse. The more important part is the t, the value of t. They have not asked you to get how much is it parallel, what is it. Okay. We just want the value of t. So t is of more concern to us. So you can substitute, look, k is equals to 60. So 4 plus 4t is equals to 2 times 60. So 4 is equals to 12t minus 4t is 8t. So your t is half. So capital T is half. This is your answer. Sorry. Okay, Azim. January 17, question number 2. T is half and everything, we've got the right answer. ठीक है, Mahad, Azim, all good?
Yeah,
Yes,
all
sir.
good.
Now you can try any question that you want from the past papers. You can say, now it's just practice. There are some difficult questions as well in this topic. Okay, somewhere you have a lot of working. For example, this 10 marks question. This was a very good one. So you have many more like these. So do the practice, bring in the questions if you have any. And there's nothing more to discuss in this thing. You know about the parallel thing, you know about the magnitude, you know about the new velocity vector, new displacement vector, position vectors, and how do you break down the displacement into its position vectors. So now it's just about the application, how you apply the knowledge that you have now on this topic.
Yes, sir.
Okay, can you take the screenshot
Okay.
or do the practice? Let's see. Okay, that's it for today's class then.
Yep. Yes, sir.
Okay, chalo. Allah Hafiz. Bye bye.
Okay, thank you, sir.
Allah
Allah
Hafiz.
Hafiz. Bye-bye.
Allah Hafiz.